My name is Arild Røed. I'm the standardization manager at NEK, and I'm also, in this context, managing the secretariat of IEC TC 18, which is a standardization committee for ship and offshore international standardization. And with me today, I have Shaun Blyde from Stillstrom, which is an electrical engineering manager, and also Øystein Huglen from Maritime CleanTech, which is an industrial member organization for maritime decarbonization. So let's jump into it. You have both engaged in the standardization project for offshore power transfer. And let's start there. What is offshore power transfer?
Yeah, so offshore power transfer, we're trying to take the HV shore connections that are being used at ports globally already and has a lot of standardization work has already occurred on, and take that offshore to particularly vessels at wind farms. We've got the service operation vessels there, and they're at the wind farm basically for their entire lifetime. So instead of waiting overnight at the wind farm burning fuel, we can have power transferred from the wind farm to these vessels. But of course, we'd look to expand these to all other vessels, potentially emergency response vessels, and then longer term at ports and hubs as well. So that's what we're looking at with offshore power transfer, simply providing electricity to these vessels while they are idling or for battery charging.
So why is that needed? What's the demand for this at offshore location at wind farms, you say?
Yes, so the main driver is decarbonisation. So that's obviously fueled by climate change, the agenda around that, but also we can see cost savings in the long run, reducing the operational costs of these vessels, particularly with certain regulations that are coming into force around clean fuels, carbon taxes, and the like.
Okay, so it's demand from regulators. So it's is it purely that, or is there some business model that could, are there any benefits as well, or is it only by force they have to do this?
No, it's certainly not only by force. I think that's, you have the carrot and the stick. That's a carrot that can make the business case better, provide or possibly be the stick in the tax side of things. But we see a positive business case for many of these scenarios already. That's without additional regulations in place. There's maybe some risk elements that have to be worked through, and we need to reassure our clients that their operations, their standard operations, will not be impacted. But generally speaking, we see a positive business case. It is a commercially ready technology.
And if I may also add on that, there is a general industrial trend on global scale for electrification, and that is giving a lot of improvements and progress with all kinds of systems. We know very well, at least in Norway, the electrical car development and how much more cost efficient and competitive that is becoming already. And we see it also in other parts of the industries, like electrical drive on cranes and all kinds of systems. And this is, of course, coming also to vessels and ships. And it's the most efficient way to give energy from source to deployment. So it is kind of more or less obvious that it will go in the direction of electrification. So it's going to be a good business case, better and better, to charge vessels also offshore.
So are these, what comes first? Is it are the ships now that can do this charging, or do you need to build out this infrastructure first?
It is a little bit chicken and egg. You do need the ships to make use of the chargers, but you need the chargers that the ships can make use of. There is currently a vessel being built in a shipyard that will be primarily battery electric, and it is an SOV for a wind farm. It will retain some diesel or methanol potentially generators as a backup or as range extension, but its primary purpose is to operate on electricity, and it is looking for an electric charger. effectively to power this vessel offshore.
And this is coming along from other segments in shipping as well. In Norway, we know very well the electrical ferries, being, of course, first users on this. And so very much of the systems and very much of the business cases are coming across from other sectors. And also into offshore vessels, we see a lot of hybridization, where the first part is to charge by the engines on board, but to use the charged energy and batteries as typically as peak shaving, for example, where you actually take the peak loads and then reducing the efforts on the engines. So it is coming along and moving into this segment nicely and smoothly, I think.
Yeah, if I may add, there's also a tender out by the Dutch government for these emergency response vessels, and it is a part of the tender that there will be offshore power transfer as part of that.
Okay, so things are moving on, you say, but why do you need to standardize then?
There are definitely a need for innovation in this industry too, and maybe in the early beginning, the innovation must be prioritized. But going forward, it is a benefit for everyone that we can also standardize in terms of giving more flexibility on use of assets, in terms of getting down costs when you scale up production, in terms of better safety and functionality and these kind of things that is kind of coming. So I think there is a chain of development where standardization come in as a very important step in this at this point.
In this project that you are involved in now, what are you actually standardizing in this project?
Yes, so I'm part of the TC18 Joint Working Group 28 working on HV, shore power as well. And we were looking at the standard that exists, the 80,005-1 standard. And we see some gaps in that standard when we try to apply it to offshore power transfer. And maybe not only gaps, but some road bumps, if you like.
So these are the standards then that are already in place for shore connections.
Yes, that's correct.
Yeah.
They haven't really been applied to the service operation vessels to date, but of course that's not our only scope. But we wanted to take this idea offshore and provide standardization offshore for these vessels while keeping a view on the larger market for offshore power transfer. And we saw that there needs to be some tweaks. So we have based it off the existing standards so that these vessels can use the same infrastructure on board, but there will be some minor changes because the marine operations in particular are vastly different offshore, and the environment doesn't lend itself to the same connector types and things like this. So that's why we needed to make some changes, and we have done this while keeping the core of the HV shore connections in place.
And the end results here will be an NEK document, right? And not an IC document. Can you just elaborate a little bit on that? Yes,
so this document was commissioned by the partners with NEK in order to get something moving quickly. I will add that our clients or prospective clients are asking us around how do we see a standard evolving? How do we make sure that this vessel is set up for the future and is not just set up for a Stillstrom charging system? And we need to provide that to them. So we wanted to do this as quickly as possible to establish a base and make sure that the industry is headed in a common direction. And then the intention is to provide this to the IEC. There is a task force already existing within the IEC Joint Working Group to work on offshore power transfer. And we'll provide this white paper as a starting point into that, and then it can be discussed on the global stage. What is appropriate moving forward, whether it's fit for purpose as it is, or get some various critique in on what we've produced.
Mm-hmm. Yeah, because I can pitch in on that it's a quite common problem in many cases that we see from NEK. that it takes too much, takes a lot of time to make an international standard. Depends on how you look at it, of course. It takes now, I think IC operates with a little more than 30 months as an average. So to develop a document, a lot of them are revisions and should basically be quicker as well. So often you have to count even a little bit more time on used documents. And maybe it's not that bad. If you think about it's an international consensus process, but still, if you need it now, it's a long time to wait. You see it everywhere, also from the European Commission. They are making new directives, regulations, and at the same time, basically, they need new standards. So this is something that I feel is going on in a lot of processes and finding out how can you make new documents that are maybe not even standards, but at least something that can be used by the market, maybe intermediate, and then in parallel while you're working on an international standard. So from my understanding, that is also the goal here, or the aim, that we will eventually also get an international standard, right?
That is the goal, and it is in the business case now for the TC18. It's within their scope of work. So I think we have an estimated date for the offshore power standard and to have a draft in a year or two, I believe, for review, and then a final standard, I think, around 3 years out. Similarly, we've looked at, and it's also in the scope of work for the same technical committee, for what we're calling inshore power transfer, which is vessels sitting just not onshore at the quayside, but potentially in a harbour zone or a fjord in Norway, or in these zones that are still offshore and require a lot of the same equipment, but maybe different considerations than fully offshore or at a wind farm or oil and gas installation offshore.
So what are we actually standardizing here? Is it just a plug and a connector with drawings, etc.? Is that it, or?
No, in fact, I would say we're avoiding that aspect because we think that is where there's a large amount of innovation yet to occur. So, as I said, the marine operations offshore are very different. We all as partners have different ways of approaching those marine operations. And the difference in the approach that we have also sort of gives necessary different views on how that connector should look. So we're keeping the same pin assignment as what the shore power connections are using, at least for the SOV vessels, which we're basing off RoRo vessels. And
roll on, roll off vessels.
Yes, thank you. Yeah, and we've kept the same pin assignment, but the connector shapes, the physical layouts may look different. And the aim is to standardize on those over time as the marine operations become more familiar and we work out what is the best to actually use offshore. Then we should coalesce on one single solution. But trying to define that now might limit innovation. So the focus really now is on how do we manage this interface, what is the connection procedure electrically, the safety elements, looking at just making sure we have quality, reliable and robust.
What are the safety risks, actually?
You are dealing with high voltage, which is in itself dangerous, but is also not common offshore, particularly on these types of vessels. So this is a little bit...
How high voltage are we talking about?
Primarily, our focus is on 11 kilovolts. We've allowed for 6.6 kilovolts in alignment to the shore power standard, but that's a little bit of a legacy voltage, we think, for this purpose. So it's often considered medium voltage, but realistically, from a safety perspective, it's quite dangerous, and people are not necessarily familiar with it in this environment.
Yeah, I think it's a quite common sort of objection to standardization, that it prevents innovation, and that's not how we see it, but we often answer questions like that. Yeah.
So and it's in this project as we describe it, we have agreed to work together with competitors to show that it is possible to align and that we will benefit from that by doing standardization together, which is then like an industry effort together to really substantiate the need for standardization. And I think it's also important to look at the end users here, in this case the wind developers and wind farm operators, that in their view, in terms for them to make decisions on using offshore charging and offshore power transfer, that from their point of view, I think that standardization is really a necessity to be able to take down risk and take down their investment, their investment risk actually.
Just to add to that one, I think that's the key objective here, right? To reduce the risk actually allows for a greater number of installations, and that just increases the potential market size for offshore power transfer and enables really the whole industry. So that's why Stillstrom is here, because we see a great benefit in opening the industry up.
Yeah, you, Shaun, are from Stillstrom, and Øystein, you're from Maritime CleanTech, but you mentioned there are others involved in this project. Maybe you have some examples.
Yes. So the project that we are involved in Norway, our organization, we don't have any IP interest, or we are also technology agnostic. But in this project, we work together with the whole value chain in a project called Ocean Charger in Norway, and we are also both end users and then the Vard group and Seonix. They have the manufacturer of equipment for charging in this case. And then we have during this white paper development, we have gathered with Kongsberg and Stillstrom. So across also the competitors on equipment production for charging systems.
We are getting close then with this white paper, and when it's finally published, what do you hope to gain from this?
I would hope we get feedback from the wider industry. So this has obviously been a little bit of a closed doors effort just to get something out a little bit sooner. It will be great to have some of our other competitors and wider industry stakeholders, particularly also our clients, become involved and provide some insights on their perspective. But longer term, or even still in the shorter term, but we'll have this task force within the IEC where we will put the standard forward for consideration, or the white paper forward, I should say, for consideration, and pull it apart basically to become a global standard, hopefully, if it's accepted as such. Otherwise, at least getting the ball rolling on producing that standard, because I think we all see a value in having that in place before too long.
And then probably obvious, but very important to say that through this work we hope that the actual installation and use of offshore charging will come sooner than it would have done if we had all been working separately on these tasks.
Very good point.
Yep. And of course, there's, from my understanding, we are working on projects that are also sort of in a certain geographical location, so that we know about a little bit about the players that are out in the sea there that will potentially use this solution. How do they get access to this? Is this by contracts with the owners, or how does it work?
Access to the white paper?
No, not access to the white paper. Access to the charging facilities. How do they proceed to make use of them and get information on? Are some ship owners, do they need to rebuild their ships now so they can charge, or?
I would say our immediate focus is on new builds because we see that market will grow and it's a little bit easier to address. I think that's also a good starting position, right? As it's a new technology to add it into a new vessel and a new wind park, for example. But as we learn and we find much easier ways to retrofit, it's also something we have been looking at along the road. But I think retrofitting becomes easier with the knowledge that we'll gain through new builds. Certainly when we look further down the road, where we look at this providing power at ports and hubs, we need to be able to provide, if we really want to achieve what we're wanting to achieve in this market, we need to be able to provide the solution for existing vessels to manage hotel load while they're sitting and idling offshore. So I think that is an end-term goal, and we'd like to hear from anyone who's interested. But primarily, right now, we're looking at the new build vessels for the wind farms, but then also, to some extent, the larger ports and hubs segments. Not just in Europe, I would say. We're also in discussions with Panama Canal around idling vessels in the lakes either side of the canal.
So that's the next, perhaps, potential market, because I was also wondering about that. We have been focusing now on the wind farms and the wind projects. So what's what could be the full potential of these solutions?
So I think, as we have heard today, the offshore wind farms, they have some good advantages that fits very well being a first mover in this. And that's important. It is about actually the availability of electrical power at the field and the ownership and the motivation to use that. But also the operational profile of the vessels is very important. So that if you have several days on location and you need to get more energy on board, it's a perfect setup. Compared to weather situations where you have more transit back and forth to shore, where it may be more difficult to supply sufficient electrical energy to the vessel operation. So there are many reasons why the offshore wind farms are the ideal starting point, and there are several offshore wind farms both in operation and coming along, of course, in Europe specifically. I think that the offshore wind farms needs to consider this option very early. So we need to push, and this is also why we need this standardization package to bring along to when we want to push regulators and operators and wind farm developers to take this into account as at the more the feasibility level or stage of the wind farm development, so that it can actually become a part of the design. And then, as you say, there are many other applications in the world, like harbors and fish farming and
aquaculture. Maybe they're going further out into the sea.
Yes,
could also be an option there.
Definitely, and the regulatory point of view to reduce the carbon emissions is coming along in all the sectors, a little bit at different stages. But I think it's also very a good point that in our part of the world, in the North Sea basin, we are in many ways in the forefront of the developments, not only the charging system itself, but the whole value chains around electrification of shipping. And that gives also an advantage in starting here and starting with the industries we have present, and then moving it along into other geographical areas and other parts of the industry.
A little bit on the side, but I just recall that we do also have subsea standardization work going on in IC. And I think the next project will actually be connectors, subsea connectors that are not for petroleum industry, because the standard we have today is for petroleum industry. It has a lot of extra requirements, obviously, and if you take away some of that, it could be cheaper equipment, etc. So that's interesting and could perhaps be used in conjunction with these solutions as well. So, Shaun, you mentioned a little bit about the requirements of the standard, the different but we kind of moved on to another topic, I think. So could you elaborate a little bit more about the content of this document?
Yeah, so some of the areas we found challenging when looking at the shore power connection was the actual environment being offshore is so much more rugged and difficult, right? So the connectors that are being used onshore are not they're not really fit for purpose offshore, because we need to be able to do an emergency release. That's very critical, right? All the vessel operators we are speaking to are mentioning that is critical, that they be able to just drop the cable and leave to go pick someone up or escape a storm or whatever it may be. So the connector needs to be capable of just being dropped in the water, maybe not as a normal operation, but to withstand that sort of operation. And then just day in, day out, salt spray, etc. Most of us, I think, are also looking at there being tension passed through the cable from the facility itself through to the vessel. So that will also likely pass through the connector interface, and that needs to be managed, which isn't currently in place with the existing standard. This is also part of the area of innovation that we'll need to work on separately. But what is definitely in common is the switching arrangements. So right now, it's very common for shore power that you have an individual on the vessel and an individual on shore, both called the person in charge for their respective areas, and they manage the switching of the system. As I've mentioned, the high voltage that we're dealing with comes with some risks. So you need these educated or specialized people who are capable of doing this. We are not going to likely have any manned facilities. These will be offshore facilities where maybe people are attending to do maintenance on occasion, but they are unmanned predominantly. So we want to be able to control the switching arrangement remotely from the vessel, and we think that's also safer. No one's climbing onto a platform. No one is operating the switchgear at the facility itself. They're managing their own zone within the ship. But of course, there are additional considerations to take in for that. So these have been accounted for in the standard. Another consideration is how do you actually manage those remote communications? It's not any longer via walkie-talkies. You need to have some sort of control mechanisms to achieve that. Another point is, where does the cable reel on the vessel go? Right now, with the shore power standard, it's a little bit dependent on the vessel. It can also be agreed to by the parties in certain instances. So we have stated that we want the cable reel on the platform, but there might also be an additional crane as part of the cable management system.
On the ship?
Yes, well, actually, either on the ship or on the platform. It depends on the marine operations that we have planned. So we need some level of flexibility while still meeting the different conditions that we're seeing in this offshore application.
Are you also making requirements such as where the connection point should be at the vessel?
Not right now. I think that ties a little bit too closely into the marine operations, so we all have slightly different approaches to that. I don't think we're all fairly well in agreement of how this should work, but there are different nuances as to how we bring the cable on board. I think in particular is the main issue that we need to over time develop and mature, because there are different methods of doing so, and there will be pros and cons to each that will only be proven over time in terms of operating this offshore.
What about the cable? What kind of cable is that?
I can only speak for Stillstrom. We are very closely following the onshore power cable, but as I've said, we need to also be able to apply more tension to it. It needs to be robust for sitting in the water. So I expect all our partners are doing exactly the same thing, but in essence, very closely aligned to what is being used onshore and just modified to fit the offshore environment.
And the communication, are you using some communication standard, or is it just a electrotechnical sort of safety circuit?
We are definitely using the existing safety loops within the HV shore connection system, and that's to be interoperable for the first part with existing HV shore power installations, so the vessel can charge onshore or offshore. But secondly, it's safe, and I think it's a proven system to have these one safety loop initiating at the vessel side and one from the facility side. So if there's any, if the connection is broken, if there's any damage to these pilots, if there's an emergency stop, if there's any reason that there is a safety issue, this system will immediately trip the same way that the HV shore connection system will work. And then on top of that, we've got a layer of operational control that will likely be done wirelessly. You could run a connection through the cable so that you can communicate between the two systems wired. But the problem is that you need to be able to communicate with the offshore facility while on the approach and before you're connecting it, because you need to control the reel, you need to do all these remote operations before you have the connection made. So it's quite essential to have some sort of wireless remote connection for communication.
Okay, interesting. Øystein, anything you want to add?
No, to be honest, we are not down to those details in from my point of view, but I'm very sure that the partners we have here together, they provide the competence and the necessary starting point for getting this into a good solution. So of course there are many other learning points behind this in offshore in the North Sea, in UK and Norway and Denmark. We have had several other systems operating for many centuries for example, loading oil and gas with similar let's say logics on emergency release and on safety circuits and these kind of things. So I think that is also an important background for getting to such good solutions as we can see in this white paper coming along.
I think that's a really good point, that nothing we're doing here is particularly new in itself. It's different applications or bringing different ways or different elements together, right? As you say, a lot of this stuff has been done on oil and gas installations for many, many years. It's just we're taking this to an electrical cable instead of a pipeline. It might be that we're using a shore power system offshore. The radio comms are, again, nothing new. So it's just about how we package these different elements into something new and assess, is there a change to the risk? How do we manage these things all together? But fundamentally, there's no real new technology. It's just made up of parts of existing technology.
So for the end user or the owner, is it the owner then of the wind farm that would normally own the installation?
Most likely, yes. They will own the facility and then have an interface with the ship owner. Okay,
so they are the ones that should state, or they could, if they want to, say that they want this installation to be built or ordered according to this document that we are making here now.
Yeah, they would be the ones requesting that. You're right. I think we see some different business models. It quite likely will be that they will own the asset itself, and perhaps they have their own maintenance crew, or Stillstrom offers maintenance. It could be that Stillstrom owns it, and they are, the vessel is utilizing it. But I think it all becomes a lot more complex also when you move away from the wind farm picture and you look at ports and hubs or other scenarios. You have different stakeholders involved. The area of anchorage is not necessarily the same as the owner of the port. You have some quite different complexities in that scenario. So maybe you are selling energy and you own the assets, or something along those lines as well. So there's very many different business models, and I think they will also come along with the industry maturing.
And also from an operational point of view, that when you operate a wind farm, the charging of vessels is one piece of a bigger picture of how you safely and operationally efficiently operate your wind farm. So it needs to be aligned with the overall philosophy and safety strategy of the wind farm in general. So that is the part that needs to be tailored, I think, to each specific business case as well.
Yes. And I think just touching on that, when we talk about the operations on the wind farm and the different, the risk appetite or the risk profiles that these wind farm operators have, there's good reason for a lot of it, but there's certain challenges also from the not just risk, but also the way that the regulations are set up and so forth, which, if they were changed slightly, would promote offshore charging in a much better way. It's very much dependent, as an example, on which state we're in to what, or the individual wind farm even, what the power price would be for a vessel charging. Is it considered part of the operations of the wind farm and they get it for free? It's auxiliary power from the system. Are they paying market rates? Are they paying wholesale rates? It's very much an unknown, and all our clients have different answers to that same question. So even if we could standardize something like that, it would also be very nice. But just some small changes or some small thinking, not small thinking, but small changes from a little bit of thinking in this area might actually really improve the prospects of the industry as well.
Make a difference.
Yeah.
Coming back to the IC then and the output of this project. So once we finished, will we go directly to IC, or isn't they're already discussing? They have a lot of things going on in that working group, that the joint working group 28, which is under TC18, cooperating with ISO and IEEE even. So they produce triple logo standards. Takes a lot of extra time. I mentioned a little bit over 30 weeks in average, but if you look at the low voltage short connection standard, for example, they've been working now over 10 years at least on that edition. Let's hope it goes a little bit faster than on this one.
I think the fact that we're basing it off an existing standard, and while we saw a need for a new standard, it's not vastly different. There's not so many discussions to be had, particularly at this early stage. I think it's beneficial to get something out there, base it off the existing work that's been done, and come to a common understanding at least. And then as the industry matures further, we can standardize on elements like the connector and the marine operations as well, which are probably the more complex parts. So this is really to make sure we're moving forward on a common understanding, and that we're not reinventing the wheel. We are utilizing all the infrastructure on the vessel that is there. It doesn't need to be new cabling, new switchgear on vessels that have already planned for HV shore power.
Yeah, and I also think it's a good approach that, I mean, making an international standard, if you start with just white papers and start and you think that you will try to just start writing with a lot of nations, even several international standardization organizations, it's going to take a lot of time. And from my experience as well, it's much appreciated if someone can bring into the work a paper which is more or less complete, and you can start the work from that position. It can save a lot of time, but also it's appreciated. I think that's my experience in ISC.
I think it also makes a difference the size of the market. So if you look at the HV shore connection standard, there's at least 50 different people involved in that task force. Last count, I think we're 4 or 5 with offshore. I hope that will grow so that we have some additional voices and some additional perspectives. But I think there's probably less hands in the standard at this point in time, so it should develop a little bit quicker, hopefully, also based on the material that it's built off.
I don't have any more questions, really. Do you have anything else you want to add?
And we can share maybe a little bit about our own companies and our own
yes,
in this area,
please.
I guess.
Yes, absolutely.
Yeah, so if you're happy, I'll start. So I'm from Stillstrom. We are a part of Maersk, the greater Maersk entity, but we operate rather independently. So you may see that we have the background with the shipping segment. But our focus has been on wind farms to date, but with the longer goal of the ports and hub segment that I mentioned earlier. We're really focusing on providing something end-to-end, so we can just speak to, right now, the wind farm clients and say, here is the product that you need for supplying electricity to a vessel, battery electric vessel in your wind farm site, and really take away all the risk element for them. I would say, if there's anyone with questions, we'd be happy to have a discussion.
Absolutely, and let's hope we'll get some feedback in this process. Also before IC, of course, in IC you have hearing rounds, etc. So it's an open and free platform, but of course you have to be a member. So I hope also that we can that companies that are not involved at the moment, they can reach out to us at the NEK and we can connect them into the IC system.
Definitely.
How about you, Øystein? For Maritime CleanTech, what does this mean for your members?
Since we are representing the whole value chain, from suppliers of equipment to ship owners to energy companies to regulators and authorities and institutions, for us it is a holistic picture about which way the world will turn now in decarbonization. And we think that this is as I said, the electrification is one of the most strongest opportunities we have in decarbonization, and that we see that we will be able to use this in a broad perspective from our point of view when we pursue further development. So what we are typically doing is we are initiating projects like this where we work together in partnerships and where we are pursuing also together with formal European Union efforts and strategies the decarbonization in Europe specifically. And we see that coming along with this, we see that the development of the technical equipment, the development of also the competence and all other aspects related to the necessary fulfillment of a decarbonized industry is the bigger picture for us. And we see, I think it's fair to say that the electrification path is probably the one that is gaining most, let's say, support and with least, let's say, bottlenecks and showstoppers involved. So this is really something we will see fruits coming from this work going forward, in our perspective. You
mentioned EU regulations, but what about the national regulations, not only in Norway but around the North Sea? Is there anything there we can expect? Yes,
I can mention examples, but seen from the highest perspective, we were disappointed by the IMO conclusions on net zero framework this fall.
The extension you got there.
Yeah, we had to wait one more year because it was to a large extent stopped by national interest in the US, to be honest. And
what does that mean? This 1 year extension?
It means to a large extent that, of course, there is 1 year delay, but I think it's worse than that because it is to some extent demotivating the world in terms of really aligning and going forward. So we hear from the markets that it's not so important anymore to participate in decarbonization because the IMO will not succeed, kind of perspective. But we think that's not the case. We think that, especially in Europe, there is still a strong force, and EU legislation is still being implemented on emission trading, on fuel EU maritime, and so forth. And if you go to national regulations, I think I know best Norway, but it's obvious that we are working on offshore vessel decarbonization requirements. That has been on discussion this fall. And if that comes as we expect it to be, direct goals or direct decisions on how to decarbonize offshore vessels, this will come directly into play for this segment. And then I think we will also start discussing electrification and offshore charging for oil and gas support vessels, like the PSV, the support vessel.
But this is a discussion going on in Norway then?
That's Norway as an example, yes. There are different levels of the regulatory development, and my conclusion is that to the extent that IMO, the global perspective, is delayed, we will see more direct legislation and requirements in Europe and in different countries. There are a little bit different approaches in different countries, but the total perspective is that at least in Europe, that each country will enforce stronger regulations going forward, where this fits very well into the solution picture.
Thank you for being here and explaining the project.